Hello, I'm Leo Espinoza, soil specialist with the University of Arkansas Systems Division of Agriculture. Extended periods of water saturation can change the chemistry of soil minerals and affect the concentration of some nutrients. I'd like to talk to you about three nutrients in particular: sulfur, nitrogen, and potassium.
Plants use sulfur in the form of sulfate. Sulfate is very mobile in soils, especially in sandy soils. It is possible that in periods of heavy and extended rain, a good amount of the plant-available sulfur moves down the soil profile out of the reach of roots. Under such conditions, consider applying 75 to 100 pounds of ammonium sulfate to prevent a yield-limiting deficiency. Fields should be monitored for visual symptoms of sulfur deficiency. In corn, these symptoms tend to appear as yellowing in young tissue, as this nutrient is not translocated from older tissue parts, but may appear as a uniform yellowing of the entire field. A sulfur deficiency may be confused with a zinc deficiency. When in doubt, collect a sample and send it to the lab for analysis. Nitrogen is another nutrient affected by rain. Crops rotated after soybean tend to benefit from the fixed nitrogen left after harvesting. However, denitrification, leaching, and runoff can reduce the amount of residual nitrogen. Denitrification is the process by which bacteria use nitrate for their metabolic activity under prolonged, waterlogged conditions. Under this type of scenario, timing of nitrogen fertilization becomes very important, as well as using technologies and practices that have proven to increase efficiency of nitrogen use. Timing of nitrogen application becomes very important under these conditions to reduce the risk of yield loss. Keep in mind that the efficiency of nitrogen fertilization is most compromised during the first 30 to 45 days of any crop, as the demand for nitrogen is not high. Once a plant has fully developed its root system and it is actively growing, it becomes very efficient at using nitrogen. A concentration of potassium in nutrient solution is very low at any given time, with most of the potassium held by clay particles which release the potassium as plant roots use it. These clay particles are held together by iron and other metals to form different types of soil minerals. Under extended saturated conditions, the iron gets reduced, which weakens the mineral structure. Research has shown that depending on the specific type of soil mineral, you may see an increase in the concentration of soil testing potassium or an increased level of potassium fixation. However, in those minerals where potassium is fixed, the amount of plant available remains the same. In Arkansas, the saturated conditions may show enhanced potassium availability in the loamy soils, while in most of the clayey soils, it should remain unaffected. Please note that under normal conditions, potassium levels in soils do not change dramatically from one year to the next, especially if a sound fertility program is in place. The value of the University of Arkansas soil testing program is not only that it offers free soil testing, but that it allows a farmer to develop a history of soil test results from each of their fields to figure out if a particular soil test result is an outlier or not.
During periods of heavy rains and saturated soil, be sure to take extra precaution when planning your fertility program. Contact your county extension agent if you need help testing your soil and understanding your soil test results.